if you're listening to this, chances are you've put out bird feed yourself, or you've watched a neighbor do it.
Oh, for sure. It feels like the purest form of interacting with wildlife, doesn't it?
Okay.
Just a simple, enthusiastic act.
Exactly. You bring a little bit of nature right up to your window, but when you scale that enthusiasm up, to a national level, the numbers involved are just huge.
They're astronomical. It stops being a small hobby and becomes this industrialized economy.
Okay, so give us a sense of that scale.
Well, in the UK, the wild bird food market is estimated at around 241 million pounds. That supplies about 150,000 tons of food every year.
150,000 tons. And what about the U.S.?
That jumps to over 500,000 tons annually. 500,000 tons of artificial resources being pumped into ecosystems.
And until very recently, the assumption was always that the impact of this was, pretty local, confined to the garden of the city.
Exactly. And that is the assumption that the source material we're looking at today completely shatters.
So our mission for this deep dive is to get into that crucial research, to ask the core question. Do these massive resources have pervasive long-distance impacts that go way beyond the garden fence?
And to answer that, the study focused on a very common bird, the blue tit. But crucially, they used a method that gave them undeniable proof of what the birds were actually eating.
Right. And that method is fecal metabarcoding. Let's just pause on that for a second because it sounds really technical, but it's the key to this whole thing.
It is, but the concept is actually, pretty straightforward. It's basically molecular detective work.
Okay, so break that down for us. How does it work?
Well, in the old days, you'd have to watch a bird for hours or, much more invasively look at its stomach contents.
Which isn't very practical.
Not at all. And you miss so much. Fecal metabarcoding changes the whole game. When a bird leaves a dropping, the feces contain tiny fragments of DNA from everything it just ate.
So you get a perfect menu of their last meal.
A perfect menu. The researchers collected these samples across a huge 220-kilometer transect in Scotland, and they sequenced that DNA. So non-invasively, they could see exactly what the birds were eating.
An etological X-ray of their diet. That is brilliant. Okay, so let's get right into what those X-rays showed. The first major finding was just how common human food was.
The ubiquity was striking. They took 785 samples right before breeding season, and over half of them, 53%, had supplementary food.
Over half. So right away, that tells you this isn't some niche urban thing.
Not at all. It's completely woven into the diet of wild birds. But the real aha moment, the thing that makes you really question the word supplementary, is when you look at the most common item they found.
What was it?
Peanut. Arachis hypogaea. It was in 49% of all the samples, nearly half.
Okay, almost half the birds were eating peanuts.
Yes, but here's the crucial bit. When they compared that to every other food item, natural or not, peanut was the single most common thing in their diet, period.
Wait, hold on. You're saying this garden feeder food, the peanut, was found more often in the diets of these wild birds than the insects they evolved to eat?
That's exactly right. To give you a comparison, the most frequent natural prey they found was a little moth, and that was only in 34% of samples.
So 49% for peanuts versus 34% for their top natural food.
It's a massive difference. It shows that we've essentially flipped the dietary hierarchy on its head. This supplement is now the main course.
It's acting as the foundational resource right before their most energy-demanding time of year, breeding.
Precisely. And they found other things too, of course. Sunflower was in 17% of samples, maize in 9%, but the peanut is the headline. It shows this is a major resource influencing the population.
Which brings us to the next big question. If they're eating it this much, how far are they actually traveling to get it?
This is where the study completely redraws the map of our influence. People always assume this distance decay effect, that the use of feeders drops off as soon as you leave the suburbs.
But they actually measure it.
They measured it, and they found that consumption stayed high for several hundred meters from the nearest house, and it continued all the way to the study's limit.
Which was how far?
1.4 kilometers away from the nearest human building. And you have to remember, that's just the study's limit. It could be even further.
Okay, 1.4 kilometers. For a bird like a blue tit, which is pretty sedentary, right? They don't migrate huge distances.
Exactly. They stick to a relatively small territory. So that finding is huge. It suggests that this supplementary food is available to basically every blue tit in the UK, even those in remote woodlands.
We've created this invisible network of feeding stations across the entire landscape.
That's a perfect way to put it. And they also saw that the birds relied on it more in some years than others.
Right. Consumption was way higher in 2015 than in 2014.
And that's because 2015 was a much colder year. Natural food, insects was probably much scarcer. It shows that they rely on our handouts the most when they need them the most.
So we have this stable, accessible resource spread across the landscape. What did that actually do for the blue tit population itself? Did all those peanuts translate into real fitness benefits?
They absolutely did. The effects were dramatic. The researchers found that more supplementary food in the diet strongly predicted a huge increase in nest box occupation.
Which is a good way to measure breeding density.
A very good proxy, yes. Yeah. And the increase was, well, it was almost fourfold. The chance of nest box being occupied went from about 20% with no feeder food in the diet, all the way up to 75% when the birds were eating almost entirely feeder food.
A near quadrupling of the breeding density. Just let that sink in. We've effectively removed one of nature's biggest limiting factors.
We have. It seems the bottleneck wasn't a lack of places to nest. It was a lack of reliable food before the breeding season. We've just erased that bottleneck.
And it wasn't just density, was it? It also affected their timing.
Yes, their phenology, when they start their breeding cycle. Supplementary food advanced the date they laid their first egg by 5 days.
Which can be a really big deal, getting a head start on the season.
It can, but it's also important to point out what it didn't affect. They found that the extra food didn't significantly change their clutch size, how many eggs they laid, or their overall productivity.
So no more fledglings per nest.
Exactly. And it didn't make the adult birds themselves any heavier or healthier.
That's a really interesting detail. It means the food allows more birds to survive and attempt to breed, and to do it earlier, but it doesn't make each individual pair a better parent.
Precisely. The effect is on the overall population size, not the output of individual nests, which is probably still limited by the availability of natural insects for the chicks later on.
And this brings us to the really critical ecosystem-level problem. If you artificially boost the numbers of a common competitive species like the blue tit, without increasing the natural food to support them,
you are fundamentally shifting the competitive balance for every other species in that woodland.
You're giving one team a massive advantage. And the study looked at this, right? The long-term trends.
They did. They did a UK-wide analysis of population trends over 25 years for 20 different woodland bird species that eat insects.
And the results were pretty clear-cut, I imagine.
Devastatingly clear. The species that use feeders frequently, like blue tits and great tits, are, on average, increasing in number.
And the ones that don't.
The species that don't use feeders, or only use them rarely, are, on average, decreasing. This strongly suggests that our bird feeders are now a major driver of national population changes.
So how is this happening? Is it just that the blue tits are eating food that others could be eating? Or is it more direct?
It's highly behavioral and often very aggressive. Blue tits and great tits are known to be behaviorally dominant. They're tough birds.
Can you give us some examples of that?
Certainly. They're known to physically evict other, more sensitive species from nest holes. Things like the willow tit or the lesser spotted woodpecker, which might have spent ages excavating that hole.
So they just steal their homes?
They steal their homes. And in some cases, it's even more brutal. They've been observed killing pied flycatchers to take over a nesting site. They also dominate smaller tits, like the marsh tit and willow tit, at food sources.
So the density increase we're fueling gives them the numbers and, I guess, the confidence to physically push out their competitors.
That's exactly it. And this leads to a phenomenon that ecologists call ecological homogenization.
Homogenization, meaning everything starts to look the same.
Precisely. This human-driven change, the massive food supply, favors a few adaptable, common species at the expense of all the specialists. You lose the diversity, you lose the complexity, and the ecosystem becomes dominated by the handful of species that can game our system.
So let's just summarize the key ramifications for you, the listener. This research shows that supplementary feeding is way more pervasive than we thought, reaching far into wild habitats.
It dramatically boosts the population density and advances the breeding of common species like the blue tit.
And these benefits are strongly linked with the long-term population declines of their non-feeder-using competitors.
And given the scale of this, people aren't going to stop feeding birds. It's a beloved activity that connects millions of people to the natural world. So the scientific community is now suggesting ways to manage the impact.
What are those recommendations? They seem pretty cautious.
They are. They focus on managing when and where we feed. For example, limiting or even removing bird feeders in nature reserves, places that are supposed to be protecting those threatened non-feeder species.
That makes sense.
Another key idea is to go back to winter-only feeding. The biggest competitive problem happens when we boost the blue tit numbers right before the breeding season, when competition for nest sites is most intense.
It's that core tension that's so fascinating. This really well-intentioned act is having these huge unintended consequences for biodiversity, far beyond the garden.
It is. We have to start seeing bird feeding not just as a hobby, but as a significant ecological force that we are wielding, whether we mean to or not.
So here is a final provocative thought for you to consider, based on what we've discussed. If supplementary feeding is tipping the scales in favor of common, already successful species, what could we do to tip them back? What kind of natural resource or habitat change could we actively implement in these woodlands to specifically benefit the declining, non-feeder using competitors? How could we deliberately rebalance the ledger that we've so accidentally unbalanced? That's all the time we have for this deep dive. Thanks for joining us. We'll see you next time.